All right, students. In this video, we're going to practice using proportions to solve everyday problems. Now, in the past, when I've taught how to use proportions, a common statement that I hear from my students is, hey, I can do this problem a different way and get the same answer. And that's true. There are many ways to solve proportion problems. But what we're doing here today is not only trying to get the correct answer, but see how to show your work as a proportion using proportions as a tool. So I want you to show your work the way we do here in the video. Now, this first situation is about basketball. Bill loves to play basketball. He shoots free throws all the time, practices and practices. He's sort of good at it. Bill makes 5 out of every 8 free throws he attempts. The question is, how many will he make if he shoots 96 free throws? This can be solved by a proportion. We'll write the proportion this way. Starting with the first sentence, Bill makes 5 out of every 8 free throws. That's a ratio comparing the number that he makes to the number that he attempts. He makes 5 out of every 8. Now the question is, how many will he make if he shoots 96 free throws? The 96 is a number of attempts, and we've got attempts in the bottom. I'll put 96 in the bottom. How many will he make? Well, that's unknown. I don't know how many he'll make yet. If he makes 5 out of every 8, how many will he make out of 96? Well, we know how to solve a proportion. You multiply diagonally, here and here. 8 times x looks like that. 5 times 96. 5 times 96 is a good problem for a calculator. 5 multiplied by 96, 480. Now divide. 480 divided by 8, I can do that in my head. That's 60. The last step on any application problem now is to label your answer. 60 what? What were we looking for? How many will he make? He'll make 60 shots. 60 shots made. 60 shots made out of 96 attempts. Got it. Now let's answer a second question about Bill. Bill's still down in the gym shooting his free throws. This time the question is, how many times will he have to shoot in order to make 45 free throws? Bill makes 5 out of every 8 free throws he attempts. How many attempts will it take for him to make 45 free throws? Start with a proportion. The first fraction, the first ratio, goes with the first sentence. Bill makes 5 out of every 8. 5 makes out of 8 attempts. How many attempts will it take for him to make 45 free throws? The 45 is the number he makes. Well, we've got makes in the top. The question is, how many attempts will it take? If he makes 5 out of every 8 and he makes 45, how many shots did he take? Now solve the proportion. We'll multiply diagonally. 5 times x, I'll put here. 8 times 45. 8 times 45 is 360. Now divide. 360 divided by 5 is 72. Last step, label that answer. 72 what? The question was, how many attempts will it take to make 45 free throws? It'll take 72 attempts. Always label your answer so we know what that 72 actually means. New situation. Now we have Debbie, and Debbie just bought a brand new bike. Debbie can ride her bike 4 miles in 20 minutes. Here's the question. If Debbie can ride her bike 4 miles in 20 minutes, how long will it take Debbie to ride 26 miles? Let's try it by proportion. The first ratio goes with the first sentence. Debbie can ride her bike 4 miles in 20 minutes. Miles and miles and minutes. Let's make it miles and T for time. 4 miles in 20 minutes. How long will it take Debbie to ride 26 miles? Now the 26 is miles. How long? That's time. Debbie can ride her bike 4 miles in 20 minutes. 20 minutes is time. How long will it take to ride 26 miles? 26 miles in how much time? Let's get a calculator. We'll multiply diagonally. 4 times x, 20 times 26. 4 times x looks like that. 20 times 26 is 520. Now divide. 520 divided by 4 is 130. Now label that answer. The final question was, how long will it take Debbie to ride 26 miles? It'll take her 130 minutes to ride 26 miles. Beautiful. Let's stay with Debbie and her bike. We know that she can ride 4 miles in 20 minutes. New question. How many miles can she ride in 3 hours? Get that proportion ready. In the first sentence, she can ride her bike 4 miles, M for miles, in 20 minutes. T for time. Now I've got miles in the top, time in the bottom. How many miles can she ride in 3 hours? 3 hours. Hours is time. That's got to go down here. But here I must be very careful. Time in this problem is in minutes, not in hours. Let's do a little scrap work. In my scrap work, 3 hours is how many minutes? I know that there are 60 minutes in an hour. 3 hours, if I multiply times 60 minutes in an hour, that's 180 minutes. I can't use hours, I must use minutes. Let's go back to the problem. Debbie can ride her bike 4 miles in 20 minutes. How many miles can she ride in 3 hours? 3 hours is time. 3 hours is the same as 180 minutes. How many miles can she ride? I've got miles in the top. 4 miles in 20 minutes is how many miles in 3 hours? Now cross multiply. 20 times x and 4 times 180. 4 times 180 is 720. And 720 divided by 20 is 36. Finally, label that answer. The question was, how many miles can she ride? She can ride 36 miles. Getting the proper label on your answer is an important part of each problem. New situation. A Toyota SUV has a 13.5 gallon tank for its gas, and it has a cruising range of 705 miles. On average, a Toyota SUV can go 705 miles on a 13.5 full gallon full tank of gas. Joe owns a Toyota SUV, and he needs to drive from Buffalo, New York to Austin, Texas. That's a trip of 1,559 miles. How many gallons of gas will he need? Let's try it by proportion. The first ratio goes with the first sentence. A Toyota SUV goes 705 miles on 13.5 gallons of gas. I'll use M for miles and G for gallons. Joe must drive from Buffalo to Austin. That's a 1,559 mile trip. Remember, I have miles in the top. If I have miles in the top of one fraction, I must have miles in the top of the other. 1,559 miles. Final question. How many gallons of gas will he need? We have gallons in the bottom. All right. Calculator time. We'll multiply 705 times X and 13.5 times 1,559. 21,046.5. Now divide. Divide that big number by 705. Oh my, that didn't come out even at all. We'll have to round that off. In your textbook, when you work the problems, it'll tell you what to round off to. I believe on these types of problems, it'll say to round off to the nearest gallon. Should I call this 29 gallons or 30 gallons? Well, the next number to the right is large, so I round 29 up to 30. We'll call that 30 gallons. Let's check, make sure we've got this looking right. The final question was, how many gallons of gas will he need? He'll need about 30 gallons of gas to make his trip from Buffalo to Austin. Now let's stick with our trusty Toyota. We know how big its gas tank is. 13.5 gallons is what it holds. And we know that it'll cruise 705 miles on a full tank of gas. Sally has one of these Toyotas, and she just put 9 gallons of gas in her tank. She needs to drive 425 miles. Will she make it on that 9 gallons of gas? Let's try it. Set up the proportion. In the first ratio, we know that a Toyota SUV goes 705 miles on 13.5 gallons of gas. Sally has 9 gallons of gas in her Toyota. 9 gallons. We have gallons in the bottom, so the 9 goes in the bottom. She needs to drive 425 miles. Will she make it? Well, I don't know. Let's see how many miles she can go. She can go 705 miles on 13.5 gallons. How many miles on 9 gallons? Cross multiply. 13.5 times X. Looks like that. 705 times 9 is 6,345. Now divide by 13.5. And what I get is 470. Now that's 470 what? I was looking for miles. She can go 470 miles on 9 gallons of gas. Now I'm not quite done. I haven't answered the question. The question was, she needs to drive 425 miles. Will she make it? Well, yes, she can go 470 miles. She only needs to go 425 miles. So the final answer to the question is yes, she will make it. Now, to properly show your work, you should show me the proportion, show me the final answer, label the final answer, And then on those occasions where there's an extra question like this one, make sure you answer the final question. Show me all of that work. That looks great. All right, your turn to go and practice some. Work hard. Show your work properly. I know you can do it. I'll see you later on today.